problem today is to look at this matrix with complex eigenvalues. This is the most recent stuff, but it's good to just go back and review one of them. So here the first step is to find the characteristic polynomial. So I subtract lambda off the diagonals and hopefully do all my math correctly and arrive at a characteristic polynomial. Then I set that equal to 0 and solve. And I'm going to have to use the quadratic formula. So my quadratic formula gives me that with a equals 1, b equals -6, and c equals 13. Pop it into the quadratic formula, and I get, in fact, imaginary roots, complex roots, 3 plus or minus 2i. So this is pretty standard. Everybody that I can think of got this correct on the exam, so I believe that everybody can do this calculation. So now we have to find the eigenvectors, which is a little bit more tricky. It's just bookkeeping. So I took the positive 3 plus 2i, and I subtracted that down the diagonal, and I get this matrix minus 2i to minus 2 and minus 2i. And now I'm going to solve this matrix equal to 0. So I set up the augmented matrix. I recognize that if I multiply the first row through by I can destroy the 2i and the minus 2i can add up to be 0. So doing so right over here yielded the following matrix, and as we know from these type of problems, it turns out that the second row ends up being the negative of the first. Now I add row 1 to row 2 and I wipe out row 2 entirely. Extracting that first equation out yields a vector minus I1, or really we're talking about the eigenspace minus I1. How do we check our work? Well, we can look in the back of the book, or if you have a TI-89, you can check your work that way. But as we know, that representation may be different than our representation. So how you can do this a different way is just check that AV is equal to lambda V. So I take A and V, and I just use the basis representation to calculate AV. And I get this vector, minus 3i plus 2 and 2i plus 3. And then I in the green have here lambda v, which is really 3 plus 2i times v, and bringing the 3 plus 2i to each component gives me exactly minus 3i plus 2 and 3 plus 2i. And I can see the blue matches the red, so they are in agreement.